assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So in this question, we have this reaction X, 5 carbon plus 6 hydrogen to give C5H12 liquid, and we are told to calculate the delta H of reaction for this particular equation. But we are given some other equations like C5H12 plus 8 oxygen to give 5 CO2 plus 6 water. And the other one has this. So we are taught to use these three equations to provide an answer to the delta H of the reaction of this first equation. So how do we go about doing this? All we need to do is to check the equation of reaction and make sure that the, for example, the 5 carbon is on the reactant side, and the same for hydrogen, and the C5H12 is on the product side. So if we check that the 5 carbon, we have carbon here, we have carbon on the reactant side in the second equation. We have hydrogen on the reactant side here, we have hydrogen on the reactant side in the third equation. And for the C5H12 is on the product side, but it is on the reactant side in this first equation. So that means we're going to need to flip this first equation. And then looking at this, we have a 5 carbon, but here we have just 1. So we need to multiply this second equation by 5. And we need to multiply the third equation by 3 because we have 2 hydrogen here and we have 6 here. So multiply by 3 to make 6. We're just going to go to the next page and do that out. So remember, we need to flip this first equation. So if we flip that, we'll have 5 CO2 plus 6 H2 to give a C5H12 plus 8 oxygen. And whenever you flip, the sign for the delta H of the reaction will change as well. So previously it was minus 3244.8. So right now it's going to be plus 3244.8 kilojoules. So the second equation we need to multiply by 5. So just go ahead and do that. So that will be 5C plus 5O2 to give 5CO2. And the delta H for the reaction is minus, let's see, minus 167.5 kilojoules. And for the last equation, we need to multiply by 3. And that will be 6H2 plus 3O2 to give 6H2O. And then the delta H for the reaction will be, we'll multiply the original value by 6 as well, by 3. So that's going to be 4H3.5 times 3. So that is minus 1450.5 kilojoules. So if we sum everything up, 5 CO2 will cancel 5 CO2, 6 H2 will cancel 6 H2O, 5 plus 3, that's 8 O2, so I'll cancel this. So we'll be left with 5C plus 6 H2 to give C5H12, which is the same thing as this equation I started with, okay, that we want to find. So that means delta H then will be equals to 3244.8 minus 1967.5 minus 1450.5, and that'll be minus 173.2 kilojoules. And that's the answer to the equation.